All right, so on those first two problems, parabolas, every parabola is just a stretch or a shrink or a shift from the original parent function. And then when you subtract on the inside, I hope you guys from doing all the problems, it means you're going to shift right however much that you subtract. All right, and so this was slide 7, and you wanted to move the black, whatever, parabola on top of the red parabola. So how do you do that? Good. So to shift that to the right, you're going to subtract 3. All right, and then to move on top of the orange, we want to go to the left. So you're going to add to go to the left. And then the green, we want to go down. So whenever you need to shift down, you're going to have to subtract on the outside of the parentheses or outside of the brackets or outside of whatever. And then blue, we want to go left again, and so that's going to be adding. All right, now when I first did this, because I always try to do it before you guys do, I messed up on number 4, and I actually wrote down what I had for a different slide. And I think some of you might have done that also. That's okay. Or if you did, just erase it. It's okay. So on these, this one is hard. So 13, we want to take this black one, and we want to move it to this one. So one thing that I noticed about it is it's skinnier. It's narrower than the original. And so to make a change on the width of the graph, a horizontal change, you're going to have to multiply on the inside. And if I want to make it narrower, actually you multiply by the bigger numbers to make it narrower. And so some of you probably tried 2x, and hopefully you saw that it did make it the right width. But it didn't move it in the right location, so it moved it kind of like this. So then I still need to shift it to the left, so I'm going to add. And then what do you do to shift it up? Add on the outside. So that was the answer for red. I know a lot of you didn't get to that, but that's okay. All right, and then for orange, when I compare the original to the orange, it's shorter. Like it doesn't reach the same heights. And so if I'm going to change a vertical thing, then that's going to be outside. And then it's also shifted over to the right 5. And then blue's got a lot going on. So if we compare the original to the blue, what's one thing you guys notice? Yeah, it's upside down. So to flip it upside down or flip it on the x-axis, you put a negative in the front. And then we also are going to need to shift it to the left, and it's 6 units to the left, and shift it down. Now I like this activity because you can see, like, as you do one transformation, you can see what happens. So then it helps you get the next one. Yeah, are you on slide 13? And you typed in 1/2 f of x minus 5, and it's not on top of the orange? 5? Yeah. Yeah, it doesn't look like a 5. You're right. All right. So then, based on what we just learned and what you remember from last year, hopefully, if you subtract 4 on the outside, what is it going to do? Down 4. Good. And what about subtracting on the inside? Right. All right. All right, and then multiplying on the outside changes the vertical height. So multiplying by a bigger number on the outside is a vertical stretch. And a smaller number on the outside is you can say vertical shrink, or you can say vertical compression. I think in Algebra 2 you learn compression. That's fine. Shrink is a shorter word to write. If you would rather write shrink, I don't have a preference. It's fine. All right. Let's look at the table on the back. All right, and last year in Algebra 2, I think you guys probably did a very similar table. So if we're going to do a vertical shift, this is where you're going to have to add or subtract on the outside of the function. All right, and then it's going to shift up when C is added. So for example, it would be like y equals the square root of x, and then after the square root, a plus 1 would shift it up 1. And then you're going to shift down when C is subtracted. So that would be like y equals the square root of x, and then outside the square root, do a minus 2. All right, so anything that is going to make a vertical change is going to be outside of the function. Anything that makes a horizontal change is going to be inside of the function. And there's something I always tell my pre-calculus and Algebra 2 students is that when we're talking about the inside lies. So it's going to tell you the opposite of what you would think. So to move right, you're going to do kind of like a negative thing. You're going to have to subtract. So that would be like y is the square root, and then under the square root, x minus 3. And then we're going to move left when we're adding inside. So the square root, under the square root, x plus 4. All right, and then dilations are stretches, and compressions are stretches and shrinks, however you want to word it. And they happen whenever you're multiplying. And again, anytime there's a vertical change, it's going to happen on the outside. So multiplying on the outside is a vertical dilation. It makes the graph taller or shorter. And I really wish I would have not printed this, so I could have changed it a little bit, but I would have added vertical. You have a vertical, that doesn't say vertical. You have a vertical stretch. If you multiply on the outside and the C is greater than 1. So that's like if you would have the square, you would have y equals 2 square root of x. And then there's a vertical shrink when you multiply on the outside by a number that's between 0 and 1. So some fraction or decimal on the outside is going to make the graph shorter. And again, anything that happens on the inside changes horizontally. So if I want to stretch the graph horizontally, make it wider or make it narrower horizontally, we're going to multiply by a number on the inside. And that's going to be a horizontal horizontal shrink or a horizontal stretch. And don't forget that the inside lies to you. And so it's going to be opposite of what you think. So if you made it to the slide where you had to kind of stretch it horizontally, you probably figured this out. But the horizontal shrink is going to happen with the bigger numbers when C is greater than 1. That's going to make it narrower. And the horizontal stretch is going to happen when that number you're multiplying by is between 0 and 1. So that's like the square root of 1/2 x. So I think that one you had to do to make it match the blue, you had to multiply by 1/4 on the inside. All right. And then to do a reflection, it involves a negative. And so if you want to reflect on the x-axis, the negative is out front. And that flips it upside down. So that would be like y is the negative square root of x. And then if you want to reflect it on the y, flip it sideways, that's going to be the negative on the inside, or the square root of negative x. I had a student a long time ago that told me the way she remembers the inside and outside for the negative is she would call it the yin side. So y and then inside helped her remember it. And I still think about that whenever I'm trying to remember which is which. So it's one more thing to remember, a little trick. The inside lies, and then for the reflection on the y-axis is on the yin side.
If you go to horizontal shrink, just the equation you use for
Horizontal shrink, I have y equals the square root of 2x. Okay, these examples should go pretty fast. I think we're going to finish right before the bell. So on number 1, we're going to do 2 things. We're going to tell the parent function, which we practiced yesterday, and then we're also going to give the transformations. So if you guys remember about the parent function, you just strip away all the addition and subtraction and multiplication. And what are you left with on this one? What kind of functions? X squared, good. All right, and then the transformations, this one actually has 2. So if you look at the parent function, if there's anything that's different in the original, it does some kind of transformation. So what does this multiplying by 2 do? Is it inside or outside? Outside, so it's vertical stretch. All right, and then what about that minus 3? Down 3, good job. Yeah, subtracting on the outside. So if it's not inside parentheses or brackets or a square root or absolute value or something, then it's on the outside. All right, what do you guys think about the parent on number or letter B? Absolute value of x. And this one only has one transformation. Subtracting on the inside, right 4. All right, you guys try to see on your own. Find the parent, and then it has 2 transformations. All right, so did you guys get reflect on the x-axis and a horizontal compression?
is it compression?
Compression or shrink, however you want to word it. But since you're multiplying by a big number, it's going to shrink it on the inside because the inside's a liar. All right, so on number 2, we're going to do the opposite. We're going to have the parent function and the transformations. We're going to write the function. All right, so we have to call it something. What do you guys want to call it? F of x, g of x, h of x? Jesse, go ahead and put that in there, please. F, okay. And if the parent function is a square root, we obviously have to have a square root. And we have to have an x. It's not going to be a function without the x. Well, I guess it could be, but not a good one. It won't be a square root function without the x. All right, so I want to go to the left 7. So what do I do and where do I do it? Plus 7 on the inside. Good. And I want to go up 2. So what do I do and where? Outside? Plus 2. Good job. That's it. All right. And then number 3 is slightly tricky. I think, well, actually, if you just look at the shifts, you should be able to figure it out. So the original parabola graph looks something like this. So which one of those choices do you think is the answer? It's like it shifts right and down. So yeah. And there's also a vertical stretch. So the graph gets taller. All right. And then number 4, Pilar, I think is how you say that. I don't know for sure. His parents give him an allowance as A of T based on his age, which is T in years. Which of the following expression would give the allowance of his younger sister, who, if she is 3 years younger than him? What do you guys think? It's going to be C. That 3 should be multiplied by his age. Not multiplied, sorry. That 3 should be subtracted by his age. All right. So you guys make sure you log out of the Chromebooks. I know you all shut them.